Hiya, it's Mr. Baker here with another physics video. Today we're going to be looking at Redshift. Okay, so today we're going to be looking at Redshift and we're going to be answering this question: is the universe infinitely big? So let's start off by looking at this question then. How many stars are there in the galaxy? And how many galaxies are there in the universe? Why don't you have a quick guess? So on average there are about 100 billion stars in a galaxy. There are lots of galaxies in the universe. Estimates range from 200 billion to 2,000 billion or 2 trillion. Right, so let's have a look at the Doppler effect. You'll all have heard the Doppler effect. It's this effect here. It is when something goes past and goes nina, 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 like that. You'll all have heard it. But why exactly is it happening? So let's have a look at what's happening. Okay, so you're standing on the road or on a pavement by the road, and the ambulance comes along and it's going Nina, Nina, and you can see that those waves are the waves there, and you can see the wavelength of the waves, and those are quite close together, so that makes a higher pitched sound. Nina, Nina. When the ambulance is travelling away from you, you can see that the distance between those waves is further, the wavelength is longer. So if the wavelength is longer, then the pitch is going to be lower. So instead of the Nina, Nina sound, it's going to be a Nina, Nina sound. So when the ambulance is coming towards you, it's high pitched. Nina, 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 Nina. And when it goes away from you, it's low pitched. The wavelength is longer. So this is because the ambulance is kind of chasing after its sound on the way there. So the waves are squashed together and it's moving away from its sound as it moves away from you, and so its wavelength is longer. But how does the speed affect the Doppler effect? So you can see here we've got the distance between those waves. When the ambulance is going quicker, you can see that the waves ahead of it are closer together and behind it they're further apart. So it makes the Doppler effect more pronounced. The larger the speed, the larger the change in frequencies, the larger the Doppler effect. So the Doppler effect is about this change in frequency as an object moves relative to you. As it moves towards you, the waves get squashed together, the frequency is higher. When it moves away from you, the waves get spread apart and the frequency is lower. So that happens in sound, but it also happens in light, and this is why it's so useful. So in the same way that a sound moving away from an observer is lower in frequency, the light we observe from distant galaxies is shifted more towards the red low frequency end of the spectrum. A lower frequency means it has a larger wavelength. This means that distant galaxies are moving away from us. It's also been observed that the further the galaxy is away, the greater the amount of redshift. This means that these very distant galaxies are moving faster than the galaxies closer to us, indicating that the universe is expanding. When we split up white light, this is the spectrum that you would expect to see. And light from galaxies and stars split by prisms appears as a spectrum of these colours. You can also see is that the spectra here have got these dark lines across them, so they're not just continuous spectra. The emission spectra has a fingerprint of absorption lines. The light is absorbed by gases around the stars in the galaxies. This tells us what the star is made of and how big it is. If the light source is moving away, the absorption spectra look a little different. You can see that the absorption lines are all moved towards the red end of the spectrum where the wavelength is bigger. So this is the same star. The spacing is very similar between those lines, but you can see that all of those lines have been shifted towards the red end of the spectrum. They've been red shifted. So now let's look at Hubble's law. Edwin Hubble was born in 1889 and died in 1953. He was an American astronomer who played a crucial role in establishing the field of extragalactic astronomy and is generally regarded as the leading observational cosmologist of the 20th century. In 1929, Edwin Hubble compared the light from stars in distant galaxies to the light from our own sun. He discovered that the light from distant stars was redshifted. This means that it had a longer wavelength. So they must be travelling away from us. He also found that the further the galaxy is, the greater the redshift, so it must be moving faster. The conclusion is that if all galaxies are moving away from us, then the universe is expanding, the further ones moving quicker than the closer ones. His observations help us to determine the age of the universe, which we'll look at next lesson. Hubble's law states that the distance a galaxy is away from us, the faster it will go. The recession velocity is directly proportional to the distance. This wasn't what scientists expected, and is explained by something called dark energy. Okay, so let's summarise redshift then. So light from other galaxies has a longer wavelength than expected. This shows that these galaxies are moving away from us very quickly. This effect is seen to a greater extent in galaxies that are further away from us. This indicates that the further away the galaxy is, the faster it's moving. This evidence leads to the conclusion that the universe is expanding. Okay, so that's the end of this lesson on redshift. These are the things you should be able to do. You should be able to describe the structure of a galaxy. You should be able to state the evidence for galaxies' movements. You should be able to describe the Doppler effect and compare galaxies in terms of their redshift and distance from us. You should also be able to compare the emission spectra of moving objects with those of non-moving sources. And you should be able to explain how redshift data is used to show that the universe is expanding. So this is the question we asked at the beginning of the lesson. Is the universe infinitely big? So light travels at 300 million metres every second. We use the term light years when talking about large astronomical distances to describe the distance light travels in 1 year. This distance is 9,500 trillion kilometres. We don't think that the universe is infinite because of the evidence from redshifted galaxies. Nearly all galaxies we observe are moving away from us. The conclusion from this evidence is that the universe is expanding. Astronomers have calculated the diameter of the universe to be 92 billion light years. We'll look at how this is worked out next time when we look at the Big Bang Theory and the age of the universe. Okay, so that's been our lesson on redshift. I've been Mr. Baker. This has been another physics video, and I'll see you next time. Thanks very much.